I'm sure there'll be a few stragglers joining us, but welcome everybody. Good morning, good afternoon, good evening, wherever you are in the world at the moment. I'm one of the founders of the Cubics Group. We're an Oracle Platinum partner company. We operate around the world doing ERP, EPM, and BI with a healthy dose of machine learning and things as well. Alongside our customers. But the point today is that I've been volunteering for a while with the Analytics and Data Oracle user community. I work alongside a bunch of amazing people, actually of which Mark is one of them. It's just an honor, a huge honor to be involved with this group of people. We have a lot of good content and good fun along with it. So today you'll see already that I've got Mark Hornick who will be presenting for us, and he's going to be introducing Oracle Machine Learning for Python. And I'll tell you a little bit more about him in a few minutes. In fact, I could take the whole session telling you about him. There's plenty of qualifications there. At the end of the talk, we'll have some Q&A. Just to mention, if you do have questions for us, please use the Q&A icon. Do not put them into the chat. We'll be covering the Q&A and looking at it to see the questions, but don't put them in the chat. We will use the chat to communicate. Carrie, who's helping us with this, will cut and paste some of the links that you'll see on the deck into the chat so you can easily get hold of them. The slides also will be made available at some stage. So in terms of our tech casts, just to say that we've had a number of amazing ones. I think the ones that are spotlighted are fairly old now, and we're almost through 2020. But they are, yeah, Wayne van Slees, Charlie Berger. They're some of our well-known people anyway. So, but there's a vast archive of really useful tech casts there for you to consume. On the December the 3rd, we've got my friend Patrick Wheeler will be coming and talking to us about building a sophisticated data platform in the cloud. And that's actually taking us through a lot of the newness that's coming out in the product set. I've just seen part of this presentation, in fact, this week, and it's really worth having a look at. On December the 17th, one of my favorite people, Opal Alapat, will be talking to us about the You Complete Me, the long-awaited union of Oracle EPM and Analytics Cloud. Again, particularly interest. Opal's come really from a background of EPM, but like me, has been dragged into the analytics world. So there's some good stuff coming up. There's lots of previous tech casts that you can go and see in our library. You'll find them both on YouTube and on our website. I just wanted to highlight to you, maybe we could look at the ways to connect slide, Mark. Yeah, we've got a lot of different ways. Oh, sorry, I'm jumping the gun, aren't I? Just to give a spotlight, January the 26th to 28th, very important, it's just after my birthday, in case anybody needs to send me a present. We've got our TechCast Days winter session. We are obviously always looking for good submissions in terms of abstracts for that. We've got a number of good sessions already lined up for this, and it will be 3 days across the 3 streams that we work with. Effectively, that'll be the machine learning, it'll be analytics plus, and the graphical, so spatial and graph type stuff. So it is, if you can mark your calendars, you will be fat and rested after Christmas. So January 26th to 28th, go in your diaries. Then the ways to connect. We are now actually trying to really broaden our community and give you different ways of getting hold of us. We have a Slack channel that you can join. Again, these, Carrie will cut and paste these if she hasn't already into the chat. We have a newsletter that comes out. This is published, it consumes articles from around the web and presents it to you in bite-sized chunks. Obviously, we've got a LinkedIn site. You can Twitter us at, if there's such a phrase, at Analytics and Data. And we also have a Facebook site. So we'd love to hear from you. We'd love to join with you in growing this community. So all of the information in this TechCast, including Mark's information, will be put up in the archives, and you'll be able to see a recording of this as well. If we could just encourage you, we'd really love for you to submit your own abstracts. We're interested in hearing how you do things. Often people have a very innovative way of using Oracle products, and we're interested in how you do that. If you can submit an abstract, you'll certainly be considered to do one of these TechCast slots. So I think without further ado, I've done enough talking. I'd like to introduce Mark. So Mark, as well as being very posh and very together, and we were saying before this started, totally organized, one of life's more organized people. He is the Senior Director of Product Management at Oracle Machine Learning, for Oracle Machine Learning. He leads the OML PM team and works very closely with product development on product strategy, positioning, and evangelization. He's got over 20 years of experience. I think he's being very short-circuited today. He's probably got a lot more than 20 years of experience integrating and leveraging machine learning with Oracle. He works both with internal and external customers in applying Oracle's machine learning technologies. He also is involved in writing material for 2 blogs, blogs.oracle.com/r and blogs.oracle.com/machine learning. Again, we can carry, if you don't mind pasting those into the chat, people can then have them as a link. And he's also Oracle's representative on the R Consortium's board of directors and an Oracle advisor and founding member of our little analytics and data Oracle user community. So with all of that, I told you I could take up the whole session. I'm going to hand over to Mark, and yes, just to reiterate, please put your questions in the Q&A slot, and I will choose whether to interrupt Mark or wait until the end with your questions. Thank you, Mark.
Well, thank you very much, Roger, for that great introduction, and really appreciate having the opportunity to speak to this group on Oracle Machine Learning for Python. So welcome. And in this session, we're going to start with a brief overview of Python and Oracle Machine Learning product family. And then we'll focus on features and functionality of Oracle Machine Learning for Python, which is coming soon. This is Oracle's standard safe harbor statement, which you've probably seen many times before. Now, if you're attending this session, I'll bet you're aware that Python is an interpreted, object-oriented, high-level, and general-purpose programming language. Now, it's an open source project, and it's designed for rapid application development and scripting and connecting existing components together. Python, what's really great about it, is it has a rich set of packages for data exploration, preparation, and machine learning. And overall, there are like 200,000 plus packages in that environment. And as shown here at the bottom there, you see that Python is developed under an OSI-approved open source license, making it freely usable and distributable even for commercial use, which can make it quite appealing to enterprises. Now, while Python has many benefits, there are also some challenges for working with larger data sets, whether local on disk or from database management systems. And this data may be accessed from flat files, or if it's in databases, maybe you make requests from IT or the DBA to get extracts, to get the desired data from the enterprise data warehouse. Unfortunately, this may require several iterations, as the full set of data that you need for a given data science project isn't always known in advance. And for those users who have access to connectivity packages like CX Oracle, they can access data programmatically, directly from the database schema. However, this data needs to be pulled from the database each time it's worked on in the Python engine. And this introduces data access latency. That is the time it takes to pull data from the database or from files on disk into the Python engine. It may also require a paradigm shift from using the Python language, perhaps to whatever data access language is required by the data source. In many cases, that's SQL. As an in-memory engine, Python needs to load data into memory before it can process it. If the data doesn't fit in memory, users need to get creative to sample or partition the data in such a way that it can be processed in chunks. The Python engine and most Python packages are single-threaded, and as such have limited performance and scalability, even when using large multiprocessor machines. There are specialized packages to enable parallelism, but these may also require additional programming and sophisticated algorithm redesign. Now, whenever there are separate processing engines involving data extraction and production deployment, solution engineers need to take into account project backup, recovery, and security needs. And these can be significant challenges for enterprises leveraging pure open source or other third-party software. In addition, production deployment code enabling integration with enterprise applications or dashboards may need to be developed for each data science project, possibly involving cron jobs to start up Python engines for processing. As we discuss in this session, Oracle Machine Learning addresses these issues. So let's briefly touch on the broader Oracle Machine Learning product family that supports data science projects. Oracle Machine Learning provides interfaces for three popular languages: SQL, R, and the focus of this session, of course, which is coming soon, Python. For interaction with autonomous database, we provide OML notebooks based on Apache Zeppelin with SQL and Python interpreters. Oracle Data Miner, which you might have seen in some past TechCasts, is a SQL developer extension that enables users to create, schedule, and deploy analytical workflows through a drag and drop user interface. Oracle Machine Learning for Spark provides machine learning in the big data environment with native scalable algorithms, as well as Spark MLlib algorithms included in the same framework. Also coming soon are the Oracle Machine Learning AutoML UI. This is a no-code user interface that automates model building, selection, and deployment. And we have Oracle Machine Learning Services, a REST-based service for model deployments and management, along with cognitive text. So on Autonomous Database, Python users access OML for Pi via OML notebooks, which provides a collaborative user interface based on Apache Zeppelin technology, further extending Autonomous Database as a data science platform. Data scientists, analysts, developers, and DBAs can use both SQL and Python in the same notebook, using the most appropriate language for the problem at hand. They can also view notebook changes by team members in real time, interactively. And these same data science team members can explicitly share notebooks and templates by granting access permissions to other users. Users can version notebooks as well as schedule notebooks to run at the same time or on a repeating schedule. Now, by virtue of being included in Autonomous Database, machine learning functionality is automatically provisioned and managed. Through Oracle Machine Learning Notebooks, users have access to the in-database algorithms and analytics functions to explore and prepare data, build and evaluate models, score data, and deploy solutions. So now let's focus on OML for Pi. Oracle Machine Learning for Python leverages the database as a high-performance computing environment, manipulating database tables and views through Pandas data frame proxy objects, with overloaded functionality that is translated to SQL, transparently behind the scenes. This enables exploring, transforming, and analyzing data faster and at scale by keeping data in the database, while allowing the use of familiar Python syntax to manipulate database data. The in-database parallelized machine learning algorithms are exposed through a natural Python interface. With OML for Pi, users can build more models on more data and score large volume data faster, taking advantage of autonomous database optimizations, including autoscale. Data scientists benefit from automatic data preparation, partitioned model ensembles, and integrated text mining. And this can result in increased productivity while at the same time The powerful in-database algorithms are made more accessible to non-expert users. Data scientists and others can create user-defined Python functions and manage these as scripts in the database. Python objects can also be stored in the database as opposed to being managed in flat files. Now, these features also facilitate collaboration across the data science team, enabling convenient handoff of data science work products from data scientists to application developers for immediate deployment. Moreover, these user-defined functions can be executed in a data parallel or task parallel manner, for example, to enable scoring native Python models at scale. Results from these user-defined functions can contain both structured and image results and be accessed via Python and REST APIs, as we'll see a little bit later. Oracle Machine Learning for Python also supports automatic machine learning, or AutoML, which not only enhances data scientists' productivity, but also enables non-experts to use the benefit from machine learning. AutoML can help produce more accurate models faster through automatic algorithm and feature selection and model tuning and selection. In addition, model explainability, or MLX, provides model-agnostic identification of important features impacting model predictions. AutoML and MLX are core technologies developed by Oracle Labs. So let's take a look at a few examples from the OML for Pi interface. We'll first look at the transparency layer. Now, the transparency layer of OML for Pi provides the foundation for leveraging in-database performance. Through the use of proxy objects and overloaded functions, users can take advantage of database column indexes, query optimization, parallelism, and table-level partitioning, which can greatly improve performance on database table operations. Here we see how we can create a table from a pandas data frame using OML create, specifying the table name we wish to use, in this case, Boston. In the table, if the table already exists in the database, we can use the function OML sync and specify the table name we wish to retrieve. This produces a proxy object that we can then use to invoke familiar pandas functions, like shape, head, and describe, and even take advantage of Python syntax for splitting data into train and test sets. These overloaded functions, in effect, translate desired functionality to SQL for in-database processing. This example shows the use of in-database scalable aggregation using the overloaded crosstab function. We first get our proxy object to a table called onTimeS, and then ask to count the distinct values in the destination column. This request will effectively get translated into a SQL query with a group by clause on the dest column. Upon executing this function, we see the result is an OML data frame object. And when we invoke the head function, we retrieve the first few rows of the result. Note that the results may be large themselves, so rather than pulling the entire result to the client, which requires both time and memory, the result remains in the database with a proxy object returned for subsequent use. Now, with respect to machine learning algorithms, OML for Pi 1.0 provides a Python API to a range of in-database algorithms that, like the SQL and R APIs, also support automatic data preparation, partition model ensembles, and integrated text mining. Users can extend this set of algorithms with those provided in Python scikit-learn package through embedded Python execution, which we'll discuss shortly. The in-database models produced through Python can also be used directly from SQL. In this example, we'll illustrate using the in-database support vector machine algorithm. Now, after importing SVM from the OML package and getting our proxy object, we specify the desired outlier rate in the dictionary variable settings. In the SVM function, we specify that we want to perform anomaly detection, that we want a linear kernel, and then we pass the settings. Anomaly detection uses the special one-class support vector machine algorithm, and the outlier rate indicates our selectivity for detecting anomalies, here at 1%. We then invoke the fit function to build the model and view the model details by displaying the result object. Keep in mind that in-database results can also be used in combination with available Python libraries. For example, we can use the matplotlib library to visualize results produced by in-database models. In this notebook paragraph, we first drop the in-database model, build a k-means clustering model, and then produce the cluster assignments for each row using the predict function. The visualization uses the cluster assignments and 2 of the supplemental columns retrieved from the database to highlight the cluster relationships. As we discussed earlier, embedded Python execution facilitates production deployment of user-defined Python functions. Here we show using the Python API for running a user-defined Python function in parallel that builds an sklearn linear model and returns that model. In this example, our goal is to build one model for each species in the iris dataset. Using the group apply function, it takes a proxy object, in this case, the iris proxy object, and the index column we wish to partition the data on, in this case, the species column. We pass in the user-defined function and the number of Python engines we want spawned to run this function. Now, there are several variations in how embedded execution can be used, and this example just scratches the surface. For example, user-defined functions can be stored by name in the Python script repository in the database. And the same name is used when invoking such functions through the REST API or granting access privileges to other users. OML for Pi on Autonomous Database also offers a REST interface for invoking embedded Python execution. Here are some of the REST endpoints for invoking user-defined Python functions stored in the script repository. In this example at the bottom, which is invoked synchronously from curl, we use the do-eval operation on a user-defined function called random red dots. Asynchronous invocation of REST endpoints is also supported. A new functionality that people are really excited about that we've introduced with Oracle Machine Learning for Python is called automatic machine learning. And its goal is to increase data scientists' productivity while reducing overall compute time. In addition, AutoML enables non-experts to leverage machine learning by not requiring a deep understanding of algorithms and their settings. AutoML consists of 3 main functions: algorithm selection, feature selection, and model tuning. And with automatic algorithm selection, the goal is to identify the in-database algorithms that are likely to achieve the highest model quality. Using meta-learning, AutoML leverages machine learning itself to help find the best algorithms faster than with exhaustive search. And with automatic feature selection, the goal is to denoise data by eliminating features that don't really add value to the model. And by identifying the most predictive features and eliminating noise, model accuracy can often be significantly improved with the side benefit of faster model building and scoring. Automatic model tuning tunes algorithm hyperparameters. Those are the parameters that determine the behavior of the algorithm on the provided data. Auto model tuning can significantly improve model accuracy while avoiding manual or exhaustive search, which can be costly both in terms of time and compute resources. So let's switch to a brief demonstration of OML for Pi using OML notebooks on Autonomous Database. Now, I need to switch machines for this, so bear with me as I make that transition.
You're very calm about that, Mark.
Oh, I hope that everything goes smoothly. I have a backup in case I need it. Just have to log into a separate system, and that should work for us. So far, so good.
Yes, we're sitting at 11:26, just as a timer for you.
Okay. Good. Okay, so we're opening up the notebook entitled OML for Pi tour. And what I want to just take you through briefly is a few examples of working in this environment. So as you see here, we've got Oracle Machine Learning for Python, and we have Markdown that we can use as well, as you would expect with a Zeppelin notebook. And if we connect to the database, we're going to run this first paragraph, which is a Python paragraph, and that's going to result in a Python engine being spawned in the background that connects to the database and allows us to leverage the features that I just mentioned to you before. All right, so we can get proxy objects for database tables, and the first thing I'm going to do is to create a table in the database called breast cancer from the scikit-learn data sets, and we see that it's got 569 rows from that, and we did that using the OML create function. So we're concatenating the predictors and the targets so we can create a single table that contains both of these. From there, let's say that we already had our table created. Well, we can invoke OML sync on this, in which case we'll get back a proxy object, and we can use standard Python syntax to manipulate that data, to create our predictors and target if necessary, to split using the overloaded split function here, as well as to develop the train and test data sets. We might want to look at the data itself. So therefore, let's take a look at the rows in our database table. And this is going to retrieve a few rows from that data and then display it here in the notebook environment. One of the more interesting aspects is maybe we want to get statistics. So if you use Python, you probably have used the describe function. So we've overloaded that to generate the SQL in the background that goes to the database. So whether you've got 900 rows or 900 million rows, all those statistics are going to be computed in the database, and only the summary results are going to come back. Now, for automatic machine learning, I just want to highlight a few things from how do you invoke this. We create an object algorithm selection, indicate that we have classification and accuracy, that we want to select an algorithm. Now we see, having run this, it takes about a minute or so, so I'm not going to do that here, but you can see that SVM Gaussian was the top algorithm, followed by neural network and others. Now we can choose the algorithm that's recommended, or we might decide, no, I actually want a different algorithm. And so with feature selection, again, we say with classification and the score metric of accuracy, but let's reduce the features that are most relevant for one of these algorithms. We're going to choose neural network. And from that, once we have the selected features, we can create our train and test sets. So if we have the selected columns, we've gone from 31 down to 15 that we'll actually use for this AutoML run. Finally, we do the model tuning. Let's create an object here and use the neural network algorithm, our reduced set of features, and then we get the algorithm itself, the model that produces the sort of best result for us. And we can look at the model details here. But if we'd like to go one step further and say, well, what are the actual hyperparameters that were used? We can get the best model out, in which case we see what was chosen, and we're looking also at the next best. And the only difference between these two, aside from a slight difference in accuracy, is the best model used arctan for the activations, whereas the next best model used hypertangent. So that's the AutoML features, but let's look at in-database machine learning. And we're going to switch data sets for the iris data set, which is a fairly well-known one, and we're just going to create that in a database like we did before and get a proxy object for it. So we used OML create. We'll manipulate that data a little bit further, creating additional proxy objects for the predictors and the target. And we can get a few rows back from the database there as well. But the more interesting thing is, let's do some attribute importance on that. So we're going to create an AI object. We're going to fit that to the data. And in the database, this is going to do the computation for which of the columns are the most predictive of the target species. And if we wanted to get that same result and use Zeppelin native visualization, we can do that as well, of course. But something we might want to do more so is say, let's build a random forest predictive model and score data. So using our iris proxy object, we're going to do some manipulations of this, creating our train and test data sets. And after having split that, and you see all of these come back as OML frames, basically the proxy objects. We can build our random forest model by creating a random forest object and then fitting that to the data with our train data. And here we see the result, sort of the model details, if you will, of the random forest model. It comes with its own attribute importance ranking. If we want to predict, we can do that using the overloader predict function. And we will use our test data set and specify we want some supplemental data for the actual target as well as the prediction, so that we can do a confusion matrix using the overloaded crosstab function. Let's see, did I rerun that or not? Just run this here. Okay, and then to run the crosstab as well, and we see we get that. Now for the transparency layer, let's just take a quick look at some of the functions there. We can pull data from the database back to our Python engine, and whereas we had our proxy object OML data frame, we now have a pandas data frame. So we can use that locally if we'd like. But some of the more interesting functions, we've got things like overloaded aggregate functions that all these computations occur in the database, so there's no database movement. We can filter data using standard Python syntax for manipulating that, as well as joining data. Here we're creating a temporary database table using OML push. And with that, we're going to join that to the iris table using the merge function. This is overloaded, so this effectively causes a join in the database using this new temporary table that we created, the iris descriptions. We can also do pairwise correlation. This is, again, computed in the database. So if you've got large data, well, that will all be done without having to move that data to your Python client. And there are even overloaded data visualization functions. So here you see too the box plot as well as histogram. And the idea here is that whether we have 150 rows or 150 million rows, the statistics that are necessary to produce the plot are all done in the database. And we're only returning the few select data points that are necessary to produce that result. And we can create derived variables as well. Here we're saying, well, is a petal large? Maybe we have criteria for that, or we want to have the square of the sepal length. And from that, we can also do some statistics computation on those results using describe yet again. But the last thing I'd like to highlight here from a demo perspective is the embedded Python execution. Now, we talked about that in the slides, and here's the function that is random red dots that generates 2 images and a table as well, 2 columns. And if we run that just purely in Python to see what it does, we see that we have indeed the structured content first, and then we have 2 images that are coming back. So what we're going to do next is take that same function and store that in the Python script repository. So using the function OML script create, we have that loaded into the script repository, and now we can invoke that from Python, in this case, using the embedded function do eval, giving the name random red dots as the function we want to invoke. What this does is cause the Python engine in the background to be spawned dynamically. This function is loaded into it, it's executed, and the results are returned, and we see those here available in our Zeppelin notebook. Now, you might say, well, that's good from Python, but maybe I want to put this into an application. So we also have a REST API that allows us to invoke embedded Python execution. So as you would expect, we get a token from authentication, and then using that token, we're then going to go forward and invoke our do eval, with the named function random red dots. And this will produce a result of the encoding of the images as well as the structured content that are available in the result. So I hope that gives you kind of a bit of a whirlwind tour of OML for Pi. And now I'll just switch back to the slides for to wrap this up. So just bear with me 1 second. Okay, I think we're back together. So in summary, OML for Pi provides Python access to Oracle machine learning in autonomous database. Python users can explore, prepare, and analyze data and build, evaluate, and deploy machine learning models. Through integrated automation features, data scientists see greater productivity, and non-expert users have access to powerful in-database machine learning. OML for Pi extends Python for enterprise use by leveraging the performance and scalability of autonomous database for enterprise scale datasets, but also by providing a platform for application integration with simplified production deployment of data science solutions. For more information on Oracle machine learning and autonomous database, please check out some of these links. Also check out our Oracle Machine Learning office hours, where we conduct webinars on all things Oracle Machine Learning. And so with that, thank you for learning more about OML for Pi, and I'm happy to take any questions.
So Mark, I do have quite a few. I was trying to do some, get Uncle Charlie on the case to answer some of them, but in which he may have started. But anyway,
I'm here, but I'm not seeing any of the questions. Maybe it's because I was not a panel.
Oh, I see. Okay, don't worry. I mean, Mark's finished now. I'm sure he can do it. I was trying to generate, because we've got about 11 questions. I'll zip through. We've got about 5 minutes. So let's see. So first of all, anonymous attendee says, I'm curious, why did Oracle choose Zeppelin notebooks instead of Jupyter?
That's a great question. And the reason is that when we started this effort, one of the key things we wanted to have was multiple interpreters for different languages available in the same notebook. So we wanted users to be able to share SQL, Python, and R. Now, when we embarked on this effort several years ago, we looked at what were the available options, and Jupyter, unfortunately, we found didn't have that capability. So we chose Zeppelin and pursued that going forward. It doesn't say, though, that when this is available on premises or a database cloud service, you'll also be able to use Jupyter notebooks to connect, and we'll make available a Python client for you to work in that environment as well. It's just that for autonomous database, we have the OML notebooks, and that is based on Zeppelin technology.
Great, thank you. Carrie Dyer-Kane asks, what about the OML microservices which were used by applications development? Has that evolved to OML services and thus open now?
So yes, and from a naming standpoint, we are referring to what used to be called microservice, just OML services, and that provides REST API for supporting model management and deployment as well as cognitive text. We're getting close to releasing that, but we're going to have some limited access to select users initially, and then of course going GA, which the best we can say is coming soon. That's the official line I'm allowed to say.
Yeah, so that's actually Lalita Venkataraman was asking, is OML 4PY already OML 4Pi, or Python obviously, already GA? If not, what is the timeline?
Correct. So, it is not GA yet. We are going to make, again, like OML services, make it available for a small group initially. And then again, that is in the coming soon timeframe. From Oracle standards, I think we could look from sometime early next year.
will it be included in the Oracle Cloud Free account, again from Anonymous?
Yes, I mean, if you have your always free trial version of that, the idea is that there will be a, obviously not going to run in parallel, it's going to have limited resources available to it, but yes, you will be able to try it out in the always free version.
How does the OML for Pi algorithm support compare to the in-database algorithm?
So in version 1.0, we have a subset of the algorithms that are available more broadly through the SQL API. And as we go to subsequent releases of OML for Pi, we'll be including more and more of the algorithms that we have across the entire product offering.
Great. By the way, that was a question from Varesh Jain. Then Hrishikesh Kopkar, are deep learning / TensorFlow libraries envisaged to be included in the OML for Pi?
So in terms of additional libraries, on Autonomous Database for Release 1, we're providing a select set of packages for use in that environment with embedded execution. On premises, you will be able to install whatever packages that you would like, including TensorFlow and others, on, say, your Exadata machine, the various nodes where the Python engine is installed. And so you will be able to work with those in that environment. Later, we have on the roadmap to extend in the autonomous environment users to broaden the set of packages that they have access to.
Okay.
I should note, though, that with deep learning TensorFlow, as long as OML services was mentioned, that allows the import of ONNX format models, which can be have originated from externally produced TensorFlow engines, and that can then be used in conjunction with OML services.
Great, thank you. He also asked, how do you transfer the model or object from one instance to another? Example, from dev to prod.
Sure. Well, if you've built a model, you can export those models. And we do have a mechanism for exporting models, and then you can import those as well. And so, of course, you would need access to the environment to allow you to run the specific functions for that. We're actually going to be doing an OML office hours on how to work with that in the coming months, because it will be really relevant from the OML services perspective, where not only do you want to perhaps move a model from from the dev environment to the production environment, but also to OML services, where you can access in-database models through the REST interface with OML services. So stay tuned for that, basically.
Good. And one question, Natalie Kellner asks if we could reshare the early slide of the URLs, but what we'll do is, rather than that, Carrie, could you just, again, post them into the chat for people to be able to copy again, maybe with the corrected Slack invite that you had posted most recently, if you don't mind. Then I think we're at time, but one more question from Nikolai Potapov. Question, once scored, can we send a notification out to OCI services, public or internal? I've heard the OCI SDK got implemented in PLSQL recently. Can it be used to send notifications out?
That's a good question. I don't have an answer for that. I could look up one and perhaps get back to this person. If you email me, Nikolai, mark.hornick@oracle.com, I'd be happy to give you a more definitive answer on that.
Thank you. So we are at time. Just to reiterate, this all will be, the recording of this and the presentation will be published in our archive and on YouTube. The links, Carrie has very kindly put them into the chat just a minute ago. So if you wanted to grab those before we end, cut and paste them now. And we have taken a note of all of these questions, and any that weren't answered, I see some from you, Anubhav Bhardwaj. Yeah, we'll answer those after the fact via email. So Mark, all it remains is thank you so much for a very illuminating presentation. Actually, I can't wait for the stuff to go GA. Thank you very much for your time, sir.
You're quite welcome, and thank you for having me.
All right. Thank you, everyone.